Good day to Dr. Shazarel. My name is Loka Ganesan and my matrix number is CD220032, representing group 3 from section 1, and we are going to present about the study which titled Work Study and Ergonomics Analysis of Alicia Burgerstall Operations. For our introduction, so briefly we can say that our main focus was and is to prioritizing IE application on Alicia Burgerstall, because these are the key challenges faced by Alicia Burgerstall, which are firstly peak hour pressure, where the high demand of orders versus limited physical space in workforce at the Burgerstall. Secondly, IE gap, which is industrial engineering tools are rarely used in micro enterprises such as the roadside burger stalls. Next is the impact on these things: long customer wait times, uneven service, high staff fatigue, which will affect the stall's profit. Next is problem statement of the study. Firstly, unstructured task execution, poor inventory management, and suboptimal ergonomics. So next, I'm going to present about the objectives of the study. Firstly is to study task durations and identify workflow inefficiencies through a direct time study of a burger preparation process. Next is to determine the optimal chicken inventory level using the economic order quantity, which is EOQ model, to minimize holding costs and ensure freshness. And thirdly is to evaluate ergonomic challenges at the workstation and propose improvement that enhances the productivity and worker comfortability. As for the next part, I am going to discuss about the scope of this study. Firstly is to conducting a direct time study for burger preparation tasks, including raw material handling, grilling, frying, cooking and packaging the burger. Next is to applying the EOQ model, as we discussed in the previous slide, to optimize chicken inventory, balancing order frequency and holding costs. And thirdly, assessing the current workstation layout and postures to propose an efficient low-cost ergonomic solution such as improved table height and workstation design.
The literature review include previous study related to work study and process efficiency, such as direct time and motion analysis, which are the industrial engineering principle. Besides that, previous study related the inventory management and the EOQ model along with ergonomics are reviewed and related to this study. For the research gap and study goal, most existing industrial engineering research focus on large formalized restaurant rather than mobile or roadside stall. This study aims to bridge that gap by applying time study, EOQ, and ergonomics assessment specifically to the Alicia Burger Store to provide cost-effective improvement. For an overview of methodology, which includes five parts, the first is the structure approach, which includes the define, measure, analyze, improve, control flow to address the operational challenge. Then the methodology includes core tools, direct time studies, economic order quantities, EOQ, and last is the ergonomic assessment. For the direct time study, the main purpose and objective is to identify bottlenecks and quantify the actual time taken for the burger preparation during peak hour cycles. While for the economics order quantity or EOQ analysis, the main purpose is to develop a data-driven restocking schedule that balance the ordering cost against the storage cost. While for the ergonomics assessment, the core principle and aim is to fitting the job to the man, hence ensuring the workspace accommodates the physical needs of the worker. And in short, for the methodological integration, by combining with these three tools of time study, EOQ, and ergonomics, this integrates approach ensures that productivity improvement do not compromise worker health or product quality, then achieving a sustainability output from the study. Thank you.
Now I will explain about the result and discussion. The result and analysis of the study carried out at the burger stand, which emphasized on streamlining the preparation process in order to increase the operational efficiency, particularly during peak hours. We set out the quantity, the amount of time spent at each of the process, locate the bottleneck, and then suggest some solution. Direct time study for making burger, which is the minimum daily demand for burger is 140 package per day on a working days. And then the stall is open around 5 p.m. to 12 a.m., which is 7 hours. The process cycle of the burger making can make around 20 package per cycle. The workers is rated at 105% and the total allowance is 15%. The process of making burger stated below, which is raw material handling, which is retrieving the patties and the ingredient from the stores, cooking preparation, which is preheat the grill, marinating and seasoning, cooking, which is cook the patties and then preparing the side dish, topping, which is lettuce, tomato, onion, pickle and cheese, and then lastly is packaging, which is wrap the burger using burger wrapping paper. To calculate the normal time, the formula is average actual cycle times with rating factor. And then there are five type of element, which is element A, B, C, D, and E. And the process for this element is different. First is raw material handling, cooking preparation, cooking process, topping, and packing. And then there are different types of average processing time, which is element A is 25 kilogram per second, B is 35 kilogram per second, C is 50 kilogram per second, D is 25 kilogram per second, and E is 15 kilogram per second. And then using the formula, we will get element A is 26.25 second, element B is 36.75 second, element C is 52.5 second, element D is 26.25 second, and then lastly is element E, which is 15.75. Now we go to the standard time calculation. For standard time formula, it is normal time divided with 1 minus allowance factor. And if you can see the table, there are type of job element, description, processing time, rating, normal time, allowance, and standard time. All types of process is doing manually, and then the rating for the process is all the same, which is 1.05, and the allowance is 15%. We will get the answer for element A, which is 30.88 second. Element B is 43.24 second. Element C is 61.76 second. Element D is 30.88 second. Element E is 18.53 second. And then total of all standard time, we will get 185.29 second. Based on the previous calculation, now we want to determine the operational hour required to meet the demand. The formula is total standard time times with demand. We will get the operational hour required to meet the demand. And to calculate it, the standard time is 185.30 times with 140, and we will get 25,942 seconds. If we convert it, we will get 7.2 hours. Thus, we can reduce the process time to meet the demand by nearly 12 minutes. If the element D were be fully automated vegetable cutter machine, we can reduce the standard time for topping making process and chatter more order effectively. The calculation for the new standard time stated as below, which is if we change the job element D to the automatic, processing time is 25 second, rating is 0.9, and then the normal time is 22.5, and the allowance is 15. The standard time we will get 26.47, and the total of overall standard time we will get 180.88. The total of standard time has been reduced to 180.88 seconds, which is around 7 hours. So we can save 12 minutes and then can reduce it to 12 minutes. Now I will explain about the inventory cycle to prepare the burger through economic order quantity analysis (EOQ). The daily demand for the patties is 25 patties. Ordering cost is around 9 ringgit 90 cent per day, and then holding time is RM 40 cent per patty per days. Leading time is 1 days, and then operating days per month is 25 days. For the demand per patties is 25 patties per day, and the demand per year is 25 times with 325, which will get 7,500 patties per year. The setup order, which is cost per order, and then the S is 15 ringgit per order. The holding cost is 40 cent patties per day, which is 25 days times with 12 months, we will get 120 per year. And then for the optimal order quantity, the formula is square root 2 times with D times S over H. So we will get square root 2 times with 7,500 times 15 over 120. We will get 43.30, around 44 unit. And then the expected number between the orders is D times with Q. We will get 7,500 over 45 point 40. We will get 172.81, which is 173 orders per year. And then the expected time between the orders is working days per year over N, which is 300 over 173. We will get around 2.18, which is 2 days between orders. And then reorder point, uh, ROP is D times with L, which is 25 times with 1 is 25 unit. And then the total annual inventory cost is um, D over Q times with S plus Q over 2 times H, which is 7,500 over 43.30 times with 15 plus 43.30 over 2 times 120. We will get RM 5,196.15 cent.
Hi, Assalamualaikum. My name is Luqman Hakim bin Abdul Ghani. My matrix number is CD220037, and I am group members of Group 3, Section 1. For our ergonomic analysis of the Anisha Burger stall, we started with the core principle of ergonomics, fitting the job with the man rather than forcing the worker to adapt to a poorly designed workspace. Our goal is to improve safety, comfort and efficiency within this manned machine. Environment system. Upon analyzing the current stall, we identified 5 major risk factors. First, the fixed work height forced taller workers to hunch over the shorter workers to raise their shoulders, both of which cause long-term strain. We also observe repetitive reaching for ingredients and prolonged standing on hard surface, which lead to significant fatigue. Finally, the heat exposure from the grill and poor general work layout contribute to a stressful and inefficient working environment. Next, moving on to our anthropometric analysis, we evaluated the degree of mismatch between the cart's rigid dimensions and the diverse body size of the workers. We found that the current one-size-fits-all designs fails to accommodate the range between the 5th percentile female and the 90th percentile male. Two specific conflicts highlight this failure. First is the working height. For a tall male, the counter is too low, forcing him to bend his back constantly. Conversely, for a short female, the stack grid is too high, forcing her to lift her elbows just to cook, which strains the shoulder. Second is the clearance conflict. The cart lacks a kick plate or toe space at the bottom. This forces the worker to stand about 15 centimeters away from the counter edge. To reach the food, they have to lean forward constantly. This sustained leaning creates a moment arm on the spine, fatiguing the back muscle much faster than standing upright. For the ergonomic improvement, first, our engineering control focus on physical change. We suggest implementing a goal zone layout where frequent items are placed within easy reach to stop the twisting and bending. We also recommend adding height adjustable platform and anti-fatigue mats to handle the height mismatch and standing fatigue. Second, for administrative control, we propose changing how they work. We suggest a 20-minute job rotation between the griller and packer roles. This prevents any single muscle from becoming exhausted. Finally, for PPE, we recommend supportive footwear to protect the feet and spine, along with ergonomic tools like silicone grips, spatulas to reduce hand strain. By implementing this change, LIAH Burger can create a safer, more productive workplace.
Hi, my name is DJ Fei. Now we will continue to discussion and suggestion for improvement. So for the discussion, the first one is capacity overload. Our finding of this research is direct time study shows 7.2 hours of active labor required for 140 burgers. In the imbalance, uh, 103% utilization rate within a fixed 7-hour window. The impact is the vendor is constantly playing catch up, leading to skip breaks, errors, and exhaustion. The second one is reactive management. Daily shopping trips are identified as a hidden productivity killer. Reliance on reactive logistics creates a firefighter mentally and last minute panic. So the third one is the human toll. Color environment treats the vendor as a machine, ignoring physical limits. Repetitive twisting and hard street surface cause lumbar pressure and joint strain. So for the improvement part, the first one is operational optimization. Automated vegetable cutter. Implementation for element D to drop standard time to 7 hours. Standard buffer, strategic buffer, creating a 12-minute daily rifter to transition from high stress to a controlled workflow. The second one is supply chain strategy, EOQ model, shifting to a 2-day replenishment cycle. The outcome is eliminates shock out panic and allows the vendor to act as a manager. The third one is ergonomic maintenance strategy, the layered golden zone workstation to minimize reaching or twisting, physical aids, anti-fatigue mats, and 1500 cm foot rails to preserve joint health. The wellness, localized fans and 20-minute task rotation to manage heat stress.
Last but not least, the conclusion of the study. So, workflow optimization time study is very crucial for any kind of operations to simplify time consuming tasks and to create a smoother workflow workstation. Next, strategic inventory control EOQ model is very important so that it can balance holding cost and order frequency, which could prevent both ingredient shortages and overstocking of perishables. And finally, enhanced workstation design, which is work ergonomics, which helps to reduce physical strain and long time fatigue during any kind of operation. Thank you.